Alright everyone, welcome back to the channel. Before we dive into something truly incredible about our own bodies, I want to take a quick moment to say hello and genuinely hope you're all feeling fantastic today, wherever you are in the world. Health is such a precious gift, so let's all take a second to appreciate it and send good vibes for everyone watching to stay strong, happy, and healthy. Seriously, wishing you all the very best. Now, get ready for a mind-blowing fact that sounds like it's straight out of a superhero comic, but it's absolutely 100% real science happening inside you right now. We're talking about your bones. Yeah, those hard things holding you up. Here's the jaw-dropper. Pound for pound, your human bones are actually about 5 times stronger than steel. Let that sink in for a second. Steel. The stuff we build skyscrapers and battleships out of. How is that even possible? It sounds too wild to be true, but understanding how reveals just how brilliantly designed and incredibly tough our bodies really are. First off, let's clear up what we mean by stronger, because it's easy to get the wrong idea. We're not saying if you took a bone the size of a steelite beam and whacked it with a hammer, the bone would win. Obviously, a giant piece of steel is going to be way harder to break than a single human bone. That's comparing apples and oranges in terms of sheer size and mass. What this fact really means is all about strength relative to weight. Imagine you could take a tiny piece of bone material, just the substance itself, stripped down to its basic building blocks, and an equally tiny piece of steel, weighing exactly the same. If you then pulled on both pieces with equal force, trying to stretch them apart, that's called tensile strength, or tried to squeeze them until they buckled, compressive strength. That little piece of bone would hold up to about 5 times more force before failing compared to the little piece of steel. It's a measure of incredible efficiency. Bone achieves phenomenal strength without needing to be massively heavy. Think about it. If your skeleton was made of solid steel, even though steel is strong, it would be so incredibly heavy that you probably couldn't even lift yourself off the ground. Your bones give you immense strength while keeping you light enough to move, run, jump, and dance. So, how does nature pull off this engineering miracle? What's the secret sauce inside your bones that makes them this tough yet relatively light? It all boils down to an absolutely genius combination of materials and structure. Bone isn't just one solid chunk of rock-like stuff. That would be brittle and snap easily. Instead, it's a masterful composite material, kind of like reinforced concrete or high-tech carbon fiber used in race cars and airplanes. The two superstar components are collagen and minerals, mainly calcium phosphate. Collagen is a tough, flexible protein. Imagine it like millions of super strong, stretchy rubber bands woven together in a complex mesh. This collagen mesh provides the bone with flexibility and toughness, the ability to bend a little and absorb impacts without just shattering. Then, soaking into this collagen mesh, crystallizing around it and filling in the spaces, are the hard minerals. These minerals are like tiny, super dense bricks. They give the bone its hardness and rigidity, the ability to resist being squashed or bent too far. It's the perfect partnership. The collagen prevents the brittle mineral crystals from cracking under pressure by allowing a little give, while the hard minerals prevent the flexible collagen from just flopping around like rubber. This combination creates a material that's both strong and tough, resistant to both breaking and bending catastrophically. The brilliance doesn't stop at the microscopic material level. It extends right up to the visible structure of the bone itself. If you could look inside a bone, like the big femur bone in your thigh, you wouldn't see solid material all the way through. Instead, you'd find something resembling high-tech architecture. The outer layer is dense and solid, called cortical bone. It's like the thick, strong walls of a castle. But inside many bones, especially near the ends, it's a different story. There, you find trabecular bone, sometimes called spongy bone. Picture a complex honeycomb or lattice structure, like the inside of a crumpet or a very sophisticated scaffolding. This honeycomb design is incredibly smart engineering. It uses minimal material to create maximum strength along the lines of stress the bone typically experiences. It makes the bone much lighter without sacrificing its ability to handle the forces you put on it every day, walking, running, landing from a jump. This combination of a tough outer shell and a lightweight, strategically reinforced inner core is exactly why bones are so strong for their weight. It's nature's version of optimized design, perfected over millions of years of evolution. Let's try to visualize this strength-to-weight ratio with a practical example. Imagine you have a steel rod about as long as your forearm. It's strong, right? You could probably lean on it, use it as a lever. Now, imagine that steel rod weighed the same as the actual bones in your forearm, your radius and ulna. To be as light as your bones, that steel rod would have to be incredibly thin, maybe only as thick as a piece of spaghetti or even a thin wire. Now, which one do you think would be stronger? That flimsy, lightweight piece of steel wire or your actual forearm bones? Your bones, absolutely. They provide vastly more structural support and resistance to bending or breaking at that same low weight. That's the power of bones' composite material and internal architecture working together. Your bones achieve the strength needed to support your body weight, absorb the impact of your steps, and allow powerful muscle movements, all while being light enough for efficient movement. It's efficiency that human engineering constantly strives for but rarely achieves as elegantly as biology does. This incredible strength is crucial for obvious reasons. Think about the forces your legs handle just walking, let alone running or jumping. Your spine supports your entire upper body while allowing flexibility. Your skull protects your precious brain. The fact that bones are 5 times stronger than steel per weight means they can handle these enormous daily loads without failing. It allows for the dynamic range of movement we have, from delicate finger manipulation to powerful athletic feats. If bones were heavier for the same strength, movement would be sluggish and energetically costly. If they were weaker, we'd be fracturing constantly. This strength-to-weight ratio is a fundamental reason vertebrates, including us, could evolve to move on land, run, climb, and fly. It's a cornerstone of our physical capability. However, and this is a really important however, despite being incredibly strong for their weight, bones are not indestructible. Remember that collagen mineral composite? While the minerals provide hardness, if the force is too great or applied in the wrong way, the bone can still crack or break. Think of it like a piece of wood. Wood is strong, but hit it sharply with an axe and it splits. Bones are similar. A bad fall, a direct impact, or severe twisting can overcome even their impressive strength. This is also why bone health is so vital. That amazing composite structure relies on having the right balance of collagen and minerals. Conditions like osteoporosis weaken the bone structure, reducing the mineral density. It's like the bricks in our reinforced concrete analogy becoming crumbly. The bone loses mass and its internal architecture deteriorates, making it much more fragile and prone to fractures, even from minor bumps or falls. Even healthy bones have limits, especially against sudden, high-impact forces they weren't designed for, like car accidents or severe sports injuries. The 5 times stronger than steel fact highlights their incredible inherent efficiency, not an absolute invincibility. So, what can we take away from this amazing fact? First, it should give us a huge dose of respect and awe for our own bodies. The skeleton isn't just a passive frame. It's a dynamic, living tissue engineered with mind-boggling efficiency. That strength allows us to live active lives. Second, it underscores just how important it is to take care of this incredible system. Those bones need proper nutrition, especially calcium, vitamin D, and protein to build and maintain that collagen mineral composite. They need regular weight-bearing exercise. When you walk, run, lift weights, or even jump, you're applying stress to your bones. This stress isn't a bad thing. It's a signal telling your body, hey, we're using these bones, they need to stay strong. Your body responds by constantly remodeling the bone, laying down more mineral where it's needed, keeping that structure dense and resilient. It's a use it or lose it system. Protecting your bones from excessive, harmful impacts is also key. Using proper safety gear during sports, avoiding risky behaviors, and preventing falls, especially as we get older, are all crucial parts of maintaining that inherent strength. Understanding that our bones are, weight for weight, tougher than steel isn't just a cool party trick. It's a profound reminder of the biological marvel we inhabit. It's a testament to evolution's ability to craft materials of astonishing efficiency. That strength allows us to experience the world, to hug, to build, to play sports, to dance, to simply stand tall. It's a fundamental part of our physical resilience. So next time you take a step, lift a bag, or even just feel the solidness of your own arm, remember the hidden power within. You are literally built with a material that, ounce for ounce, outperforms one of humanity's strongest industrial metals. That's not science fiction. That's the science of you. Take good care of that incredible skeleton. Fuel it well, move it often, protect it wisely, and it will continue to provide its silent, super strong support for a long, healthy, and active life. Stay strong, stay healthy, and thanks for exploring this amazing piece of human biology with me today.